Alright guys, I want to record this quick video on the basic atomic structure without getting too deep into isotopes and ions, and just kind of get you the lowdown of what's happening with the protons, the neutrons, and the electrons, and where they live in terms of the atom. So, let's go over the parts of the atom first. So the first part we have is the proton, and we know that this is a positively charged particle, and it has one mass unit, so it has a mass of 1 AMU, and it is found in the nucleus. I should probably spell that right, huh? Well, let me just undo everything I've ever done, and then I'll finally be satisfied. Great. Now we have, actually before I go on, proton, remember that's positive because it has a P. That is the best I have to help you remember that. Then you have a neutron, which has a neutral charge. You can remember that because NEUTR starts off neutral and neutron. They both start with the same 5 letters. This also has 1 atomic mass unit and is found in the nucleus. The last particle in the atom is the electron. These have a negative charge. They have effectively, and I'm going to scroll down just a little bit, they have almost no mass. And we just assume that they have practically 0 mass. And they're found in the electron cloud. Alright. So if all of those written down, and that's negative. So where do all of these things live? Where do they hang out? Well, the protons are, as we said, in the nucleus. So put a proton there. Along with them, you have neutrons. So I'll put 1 proton and 1 neutron. And I'm just going to circle them so that we know that this is the nucleus, and then put a bigger circle around them, and I'll slap an electron on that circle, because as you know, the number of protons equals the number of neutrons, or I'm sorry, electrons. Back that up, the number of protons will equal the number of electrons in a neutral atom. So let's actually use that and draw some atoms. Let's scroll over a little bit. There we go. So we have, what color do I have in here now? Yellow for electrons. So I need to bring my colors with me. It should be, there we go, it's white, perfect. Alright, so we know that the atomic number equals the number of protons and that in a neutral atom that will equal the number of electrons. We also know that the mass is equal to protons plus neutrons. That's all going to be useful in a minute, I promise. I'm not just saying it from health. So if we look at the first element, hydrogen, its atomic symbol, or atomic number, is 1. So that means I'm going to, in the nucleus, put 1 proton, and I'm looking at the mass number, the average mass number, and it's 1.01. So I'm going to round that off to 1, and if it's 1, then it's going to be my protons, which is 1, plus 0 equals 1. So I'm not going to put any neutrons in there. I'm going to leave that as it is, and put my 1 electron around it, because electrons equals protons. And there is my hydrogen atom. Now sometimes you might get a hydrogen atom with a mass of 2. If this mass had been 2 instead, I would put a neutron in. Now let's try this for helium. This video is already going long, so I'm going to wrap it up after this example. The atomic number is 2, and the average mass is 4.0. So the atomic number tells me that we have at least 2 protons, which means we have to have at least 2, and I have to figure out what the heck I'm doing next. I'm getting all mixed up. So to get to 4 as a mass, we have to have 2 neutrons. Two plus 2 will give us 4 for our mass. So if I were to draw this, I would put my 2 protons, and I'm going to separate them a little bit so that they look like they're separate protons. You can do that. Along with 2 neutrons sitting in the nucleus. And then, because protons equals electrons, I know I have to have 2 electrons. Now, electrons are kind of like me. I want to be as far away from people, typically, as I can. There are some exceptions, but most people want to be as far away from as possible. This whole quarantine thing hasn't been too bad. So electrons will be far away from each other. That's why I'm drawing them on opposite sides of the atom. So we're going to get more into this later on, but I don't want to spend any more time on this. And if you have any questions, please shoot me an email.